Hi everyone, this is Mrs. GA, and today we're going to talk about representing and describing transformations. So a little bit of vocabulary. A transformation is just a function that changes your figure, so it can either change the position, the shape, or the size of your figure. So transformation in real life means a change, so it means the same in geometry. So the other two words we're going to be using today are pre-image and image. So pre-image is an original image like you see here, triangle ABC. The image is the output after transformation. So this is changed. And notice that for the image, instead of just saying ABC, it says A prime. We read this as A prime, B prime, C prime. Okay, so we're going to talk about different types of transformations and what they look like inside your coordinates. So these are kind of the rules that apply. So if we're starting with the normal coordinate xy, first thing I want to point out is that x is always going to represent horizontal movement, just like the x-axis is horizontal, and y is always going to represent vertical movement, as the y-axis is vertical. So one way you can transform a figure is by adding or subtracting to your coordinates. So here you can see we have x plus or minus a, and that we call a horizontal translation. It essentially just moves your figure left or right. So anytime you add or subtract from a, it moves your figure left or right. We call it a horizontal translation. Anytime you add or subtract to your y value, it moves your figure up or down, and we call that a vertical translation. So translation is just a fancy word for shifting your figure. Another way you can transform is by multiplying. So here you can see that we started with xy, but we multiplied x by our a value. So anytime you're multiplying multiplying your x value, we call that a horizontal stretch or shrink, depending on if you're multiplying by a number more than 1 or less than 1. And if you're multiplying your y value by some number, a, we call that a vertical stretch or shrink. Remember, anything with x is horizontal, anything with y is vertical. Another thing we can do is actually make one of our values negative. So if we make our x value negative, we call it a horizontal reflection. So if it's a horizontal reflection, maybe it's starting here and it reflects horizontally, meaning side to side, you can see that it is actually flipping over the y-axis. So we call it a horizontal reflection, but it's actually going over the y-axis, here to here. Or if you multiply your y value by a negative, we call it a vertical reflection. So maybe instead of going over from side to side, you're going from here. So if you reflect it vertically, it goes up and down. So you can see it actually reflects over the x-axis. So again, this is what happens if you multiply one of your values by negative. And if you multiply both values by negative, it actually rotates your graph 180 degrees, which is essentially a half circle. Okay, so we're going to be practicing using those different different terminology for transformations, and we're going to give this one a try. So here we have a figure. It's a little hard to see. Let me go over it in blue. So we have A, B, and C at the origin. Okay, so it says find the coordinates of the image using the following rule. Then draw the image and describe the transformations. So first we need to find the pre-image coordinates. So I can see from our graph that A is at 0, 4. B is at 3, 0. And C is at the origin. And then I'm going to apply my rule. So you can see in the rule, it's telling us to subtract 4 from any x value and subtract 3 from any y value, and that will give us our image. So let's start with our x values. We're going to subtract 4, again, from all of our x values. So instead of a, I'll call it a prime. 0 minus 4 is negative 4. For b prime, 3 minus 4 is negative 1. And for c prime, 0 minus 4 is negative 4. So I've subtracted 4 from all my x values. Now I need to subtract 3 from all my y values. So I have 1, negative 3, and negative 3. So these are the coordinates of my image. So I'm going to plot those points and draw our image. So we have negative 4, 1. That's going to be a prime. And then we have negative 1, negative 3. That's going to be b prime. And then we have negative 4, negative 3. That's c prime. And then connect your dots. So you can see that essentially what happened is we took all of our points and we moved to the left 4 and we moved down 3. As we reviewed in the last slide, anytime you're adding or subtracting from x, it moves left or right. So we can see that since we subtracted 4, we moved left 4. And since we subtracted 3, we moved down 3. And again, these are both called translations. So there you go. So you can either see that from your actual graph, everything moved left 4, down 3, or you can see it in the rule, left 4, down 3. All right, let's try another one together. So here our rule is to multiply all of our x values by negative 1. So let's start by writing our pre-image coordinates. So we have r, and r will be at negative 4, 3. We have s, which is at negative 1, 3. And we have t, which is at negative 4, 1. And remember, our rule is to multiply all of our x values by negative 1. So our image coordinates, after we apply our rule, our prime, negative 4 goes to positive 4. Our y value stays the same. For s prime, negative 1 becomes positive 1. Y stays the same. And for t prime, negative 4 becomes positive 4. Our y stays the same. So let's plot those new coordinates. So we have 4, 3. And we'll call that r prime. We have 1, 3. That's s prime. And we have 4, 1, that's t prime. And you can see that here we actually reflected our triangle horizontally. So imagine you folded your paper on the y-axis, it reflects horizontally. Or we could say reflection over the y-axis. So whether you look at this and you say, oh, I multiplied x by negative 1, that reflects over the y-axis, or you can see it in the picture. Both should match. Okay, we're going to try one more of these together. So again, our process is to list out the pre-image coordinates. So we have j, which is negative 1, 2. We have k, which is 2, 2. And we have L, which is 2, negative 4. Our rule is to multiply all of our x values by 2. So that will give us the coordinates of our image. So j prime, well, negative 1 times 2 is negative 2. Our y value stays the same. For k prime, I multiplied 2 by 2. So 4, but our y value stays the same. And for L prime, multiply by 2, our y value stays the same. So let's plot our new points. First we have negative 2, 2, which is j prime. Then we have 4, 2, which is k prime. And then we have 4, negative 4, which is L prime. So if you look, something like this. So you can see that our triangle has kind of stretched out. So you see that it doesn't go any higher or lower because we haven't changed the y value, but you'll notice that it's kind of stretched out side to side. So we actually call this a horizontal stretch, and we're going to say by a factor of 2 because we multiplied by 2. So again, it's a horizontal stretch because we only multiplied our x value. Anything done to our x value will be horizontal. So you can see it looks like we grabbed the two sides and just pulled them out sideways. Okay, so now we're going to talk about a new concept, which is called rigid motion. So rigid motion changes the position of your figure without changing the size or the shape. So essentially, the types of transformations that will result in rigid motion are translations, which remember is up, down, left, or right, reflections, or rotation. So if you have one of those type, you'll see that your figure looks like it's been picked up off the page and maybe moved or twisted around, but the actual figure itself didn't change in size or shape. So rigid motion has these properties. It preserves distance between points. It preserves angle measures. It preserves betweenness, so where the points are and relative to each other. It preserves collinearity, and it preserves parallelism. So these are all of the properties of rigid motion. Okay, so now we are going to be looking at our pre-image and image coordinates, and we are actually going to be the ones that are writing the rule. So before we were given the rule and we found our image coordinates. Now we have to figure out what the rule is. Then we're going to describe the transformations using words, and then we're going to decide if this type of motion is rigid motion. So we have to look at the type of transformation we see. So I'm going to look and I'm going to try to find some sort of pattern in the changes between A prime, B prime, and C prime. So one thing I notice is that, well, all of my x values are changing, but all of my y values are also changing. So maybe I look from just right here, from 1 to -1. So maybe I'm thinking, hey, let's multiply by -1. Let's see if that works here. Well, in this case, that same rule doesn't apply. So it has to work for all of your coordinates. So let's try a different rule. Well, I know I can get from 1 to -1 by subtracting 2. Let's test it here. Oh, 4 minus 2 is 2. 3 minus 2 is 1. So that must be our rule for x. It's x minus 2. Okay, let's check y. So for my y value, I go from 2 to 0, 2 to 0, and -2 to 4, or to -4. So you can see that my rule, again, is subtracting 2. So actually I have y minus 2. So this is the rule that describes how to go from pre-image to image, and let's write it like this. xy 2, x minus 2, y minus 2. So this describes the rule. Now we can describe the transformations. So remember, anything done to x is horizontal. So I know I'm going to move left or right. And since I'm subtracting 2, that means I'm moving left 2. And anything done to y will be horizontal, so up or down. So since I'm subtracting 2, I'm going to move down 2. And again, these are both called translations. And there you go. So since all I have is a translation, I'm taking my figure and I'm just kind of moving it down and to the side. This does describe rigid motion. So that's the last part of our question, was to decide if it is rigid motion. And since it is only a translation, it is a rigid motion. Okay, let's try another one together. So again, we are trying to find the rule for how to change x, y into our new image coordinates. So let's first look at our x values. What you might notice is that all of our x values stay the same. So that means that x stays x. Now if we look at our y values, let's see how they're changing. Well, we went from -1 to 1, -1 to 1, -4 to +4. So you can see that all of their signs changed, which means we multiplied it by -1. So it's the opposite of your y value. So the opposite of -1 is +1. And it works for all of your coordinates, so that is your rule. So now we need to describe it. So remember from our previous slide, we said that if you multiply the y value by negative, it is a vertical reflection over the x-axis. And since it is a reflection, it will represent rigid motion. So it kind of flips our figure upside down, but it doesn't stretch our figure out or shrink in, and it doesn't change any of the side lengths or any of the angles. Okay, we're going to do one more together. So again, let's start by comparing our x values to see if we can find a pattern. Maybe I'll highlight it this time so we can compare. Okay, so we see, 3 to 9. Maybe it's add 6. If you check the next one, 1 plus 6 is not 3. So let's see if there's another way I can go from 3 to 9. Well, I know that 3 times 3 is 9. Let's check here. 1 times 3 is 3, and -4 times 3 is -12. So our rule must be to multiply by 3. Now let's check our y values. Let's compare. And what you might notice as I'm highlighting them is that they're all staying the same. So y just stays y. And that's my rule. We know that when we are multiplying one x or y by something, it's some sort of stretch or shrink. So since it's x value, we'll say horizontal. And we'll say stretch by a factor of 3 because we are multiplying by 3. Okay, in this last example, I'm going to ask you to give it a try on your own. So pause the video and see if you can come up with the rule and describe the transformation. Okay, go ahead and check. So hopefully you were able to see that the change in x values was always adding 1. So you can see x plus 1. And to go from pre-image to image for my y values, I'm subtracting 2. So since I'm adding or subtracting, we call it a translation, which shifts it left or right or up or down. So since I have x plus 1, I know it's going to move it to the right 1. And since I have y minus 2, I know that it's going to move it down 2. Since I'm just translating or shifting my figure, it does represent rigid motion. All right, that is all for today. Thank you for watching.